This exercise is asking us to find the factors of 21 using factor pairs. Now, we've already found factors of 21 earlier in the playlist, but here I'm going to do it using a different method. I will divide the 21 by 1, giving the result of 21. And you can see that this is an example of a factor pair. So I'll place these two numbers at the bottom of the slide, as you can see here, and I'll draw an arrow between them to emphasize that they're an example of a factor pair. And I've spread them out, as you can see, to ensure I've got room for other factor pairs between the 1 and the 21. I will now divide the 21 by 2, and you can see the answer is 10.5. Now, the fact that the 10.5 is not a whole number means that the 2 is not an example of a factor of 21. Consequently, it cannot belong to a factor pair. So far, I have divided 21 by 1 and 2. The next thing to divide it by is 3. You can see I'm going in the sequence 1, 2, 3. So let's have a look at that. And you can see 21 divided by 3 is 7. Consequently, I know that these form a factor pair of 21. So I will now write the 3 and the 7 between the 1 and the 21, as you can see here. And I'll draw an arrow between them to emphasize that they are a factor pair. I will move these calculations out of the way, and I will be looking in the region of the question mark, asking myself, are there any other factor pairs that can go in this gap? Well, so far I've divided by 1, 2, and 3. So clearly I can still divide by 4, 5, and 6. So let's have a look at these calculations. And you can see 21 divided by 4 is 5.25. Now, the fact that the 5.25 is not a whole number means that 4 cannot be a factor of 21. It therefore cannot belong to a factor pair. I will now continue with my division. On this occasion, I'm going to divide by 5, and you can see the result is 4.2, which is not a whole number. Now, this means that the 5 cannot be a factor of 21, therefore it cannot be part of a factor pair. I will now divide by 6, and you can see I get the answer of 3.5. Now, clearly 3.5 is not a whole number. This means that the 6 cannot be an example of a factor of 21. Consequently, it cannot belong to a factor pair. I'll remove the calculations on the question mark that was between the 3 and the 7. And now I'm going to divide the 21 by 7, which you can see gives the result of 3. Now, these two form a factor pair. Now, the thing is, if you look carefully at the factor pair, you can see it's the same as the factor pair I'm highlighting twice. So 3 and 7 is a factor pair, and 7 and 3 are a factor pair. They're one in the same. They're just in a different order. There are no other factor pairs to go between the 3 and the 7. So we've finished this division process, and what you can see in front of you circled are the factor pairs for 21, and you can see there are just two, the 1 and the 21 and the 3 and the 7. So I'll move this to the top here, and we can see that if I've got the two factor pairs, 1, 3, 7 and 21 are the factors, so I will bring them out, put them side by side, so we can say that the factors of 21 are 1, 3, 7 and 21. And we found these factors by finding the factor pairs. Therefore, we can go on to say the factors of 21 are 1, 3, 7 and 21.